Given question, determine the reactions developed for the system as shown in the diagram.
This is the question of simply supported beam, and we have to find out the reactions developed at this point A as well as at this point B. If we observe the load distribution, then here at point C 20 Newton per meter load is applied, and at the end B here 60 Newton per meter load is applied. Now we will make here one construction. I will draw one horizontal line passing through this point. So if I draw here one horizontal line, then this load is developed into two types. So if we observe from point C to from point B, here this section below the red line is known as uniformly distributed load. So I will show here it is uniformly, that is UDL. And the section above this red line is known as uniformly varying load. So I will write here uniformly UVL. So we have to solve for these two types. Now how to find out the total load for uniformly distributed load? So I will write here uniformly distributed load, total load is equal to, if we observe the section below the red line, then total load is 20 Newton per meter, and this load distributed over the length 4 meter. So total load we can calculate 20 multiplied by 4. And how to find out the point of application of this load, that is centroid. So we know that for uniformly distributed load, centroid is the middle point. So we can say that centroid is at the middle point, that is the 2 meter from point C or 2 meter from point B. Then we will move to the next for the uniformly varying load. So for the uniformly varying load, how to find out total load? So if we observe here, suppose I will give here the point X, Y and Z. So here is the triangle X, Y, Z. So total load, that is the area of this triangle X, Y, Z, that is half multiplied by base multiplied by height. So I will write here half multiplied by base. X to Z distance is 4. Multiplied by height, that is Y to Z distance. So X to C is equal to 20 Newton per meter, and Z to B is equal to also 20 Newton per meter, because this is the horizontal line. So Y to Z is equal to 60 minus 20, that is 40. So 40 Newton per meter. So this is the total load for uniformly varying load. So what is the centroid? That is the point of application for this uniformly varying load. So it is 1 by 3 meter from this right hand side and 2 by 3 from this left hand side. So we will show in the separate diagram. Now we will draw here the free body diagram for this system. So at end A and at end B, both ends are simply supported. So reactions developed will be in the upward direction at end A. So we will say that this reaction will be RA, and here this reaction is RB. Now we will show uniformly distributed load. So uniformly distributed load, total load is 20 multiplied by 4, and point of application is the middle point. So middle point, that means 2 meter from this point C. So I will show here point C, here is point A and here is point B. So I will show the point of application is 2 meters. So I will show here, this is the point of application and magnitude is 20 multiplied by 4 Newton. Now we will move for uniformly varying load. So uniformly varying load, total load is given half multiplied by 4 multiplied by 40. Now this total load, where is the point of application? So if we observe, point of application is 1 by 3, that is for this total length 4 meter we have to split into two lengths. First section, that is 1 by 3 from right hand side and 2 by 3 from the left hand side. So right hand side there is point B, so this section is 1 by 3, and here from left hand side section is 2 by 3. Now if we observe, this is the middle point, so I have shown here 2 meter. Now for this 1 by 3 we will show here the next point, and this is the point for uniformly varying load, and total load is half multiplied by 4 into 40. So I will write as it is. Now from this question we have to find out RA as well as RB. We will consider the equilibrium of this whole system, and we will take summation of moment of all the forces about point B is equal to 0. So how to take this moment of all the forces? So we know that force multiplied by perpendicular distance. Now first force we will take this RA. So RA, if I move the compass about this point B in the direction of RA, then here is the clockwise direction. So we have to use positive sign. So RA multiplied by perpendicular distance 4 plus 2, that is 6. RA multiplied by 6. Now next is 20 into 4. Now this is the point load in the downward direction. So if I move the compass in the direction of this 20 into 4, so here is anti-clockwise direction. So we have to use negative sign. So minus 20 into 4 multiplied by perpendicular distance. So if we observe, this is the middle point. So perpendicular distance is 2 meter. So minus 20 into 4 into 2. Now we will move to the next. Half multiplied by 4 into 40 multiplied by perpendicular distance. Now this total length is divided into two parts, 1 by 3 and 2 by 3. So 1 by 3 multiplied by 4. So this length is equal to 1 by 3 multiplied by 4, and this remaining length is 2 by 3 multiplied by 4. So perpendicular distance from B is 1 by 3 into 4. Now if I move the compass about point B in the direction of this load, then it is also in anti-clockwise. So we have to use negative sign. So minus half into 4 into 40 multiplied by this 1 by 3 into 4, that is 4 by 3 is equal to 0. Now when we solve this, only one unknown term is RA, and RA is equal to 44.4 Newton. Now what about RB? So RB is applied at point B only. So perpendicular distance is 0. So we are not going to consider this. So this is the first component that we get. Now we will move to the second. So now we have to find out RB. So which is in vertical direction. So we can take here summation of all vertical forces is equal to 0. So how we can take now this RA and RB in upward direction. So RA plus RB minus 20 into 4 minus half into 4 into 40 is equal to 0. Now RA is known, so only one unknown term RB, and it is equal to 115.5 Newton.